If Postgres FTS feels like magic, you're missing the ranking and tsquery rules. Let's make it predictable. By the end, you will understand how Postgres turns words into searchable signals, how ranking actually works, and how to control those results so search feels deliberate and useful. I'm Professor Pine, teaching search and IR with simple Python. Full-text search in Postgres is a practical tool, not a mysterious black box. Developers use it when they need fast, text-aware search inside a database. It sits between naive like matching and a full search engine. Success here means returning relevant rows quickly, with useful snippets and a raking users' trust. That matters for small production apps, documentation search, or a prototype before moving to an external index. At a high level, Postgres turns text into tokens called lexemes and builds a searchable vector. Then you build a query vector and the engine compares them. The tough parts are how you build the query and how you score matches. Misunderstanding either makes search seem random. A few controls change behavior a lot, like Boolean versus phrase queries, term boosting, and headline generation. Think of a tiny example. We will seed a small table, run a Boolean match to filter results, score and pick the top hit, boost title terms so titles matter more, and finally, show highlighted snippets that respect phrase and prefix matches. Each step is small, concrete, and builds on the last, so the complexity grows naturally. Now we'll create and seed the tiny table. This snippet connects via psycopg and seeds a tiny Postgres FTS table. It opens a database connection using psycopg, creates the extension if needed, creates a table with a text column and a TS vector column, and inserts a handful of sample rows. The key lines convert text to a TS vector using the toTsVector function, which turns raw text into normalized tokens. The code also shows a simple index on the TS vector, so searches are fast. This sets up a reproducible toy corpus we will query and rank in the following steps. Next, we will run a simple Boolean text match. This example runs a Boolean match using Postgres plain2 tsquery with psycopg. It sends user text into plain2 tsquery, which builds a text search query from plain text by parsing words and operators. The snippet performs a select that compares the table TS vector to the plain2 tsquery result using the match operator. Key lines show how the parameterized query is constructed and executed through psycopg, and how the database returns matching rows. This demonstrates the simplest flow, where the query acts like a Boolean filter, and you can see which rows are considered matches before worrying about ranking. Next, we will rank matches and pick the top hit. This code ranks matches with tsrank and returns the highest scoring row. It shows using the tsrank function, which scores how well a TS vector matches a TS query, producing a numeric relevance score. The snippet orders results by that score and fetches the top row, illustrating how ranking changes which document appears first. The important lines show tsrank called with the TS vector and the plain2 tsquery input, and the order by clause. There is a short note about normalization flags and how they subtly change scores. Increasing normalization tends to penalize long documents, while leaving short, dense matches higher. Next, we will boost title terms, so headlines matter more. This snippet boosts title terms using setweight to improve ranking in Postgres. It builds a compound TS vector that merges a low-weight body vector with a higher-weight title vector using setweight, which tags tokens with importance levels. The snippet updates or selects using a weighted TS vector expression, so matches in the title contribute more to the TS rank score. Key lines show set weight applied to the title to give it the highest weight, TS vector used for both fields, and TS rank using that combined vector. Changing those weights shifts the ranking. Higher title weight pushes title matches up the result list. Next, we will do phrase and prefix matching with highlighted snippets. This code combines phraso-tsquery and prefix with TS headline highlighting via psycopg. It uses phrase-to-tsquery, which constructs a phrase-oriented tsquery that prefers exact word order and enables prefix matching, so partial words also match. The snippet passes that query to TS headline, which returns a short highlighted excerpt from the matching text showing context around hits. The important lines show building the phrase to TS query, using the match operator for filtering, and selecting the TS headline output, so the application can show highlighted snippets. This gives users readable, focused results that respect phrase intent and partial typing. If you map this toy example to a real app, the weighted TS vector becomes part of your document model. The queries come from user input through your API, and the headline output is what you render in search results. The psycopg calls become the glue between Python and Postgres, so you can tune behavior without moving data. Recap what it is. Postgres full-text search turns text into searchable vectors and uses tsquery to match and tsrank to score. When to use it? For in-database search, where latency and simplicity matter, and you do not need a separate search service. One caveat: ranking defaults and query types can surprise you, so you must tune queries and weights for predictable relevance. Next step: tune the ranking by adjusting set weight values and TS rank normalization to match your users' expectations. Then measure changes on real queries. If short, practical IR helps, subscribe and watch the IR videos.